This video looks at how we can use the exponential function to model populations. And we're given a model, p equals 7 minus 2e to the minus kt. Now k is currently unknown. Now part 1 just says, suppose t equals 0, what is the population? Now for this we just put 0 into the equation, so p equals 7 minus 2e. Well, when t is 0, it becomes e to the power of 0. Now don't forget, e to the power of 0 is 1, so it just becomes 7 take away 2 equals 5. So the population is 5 million. Not 5, but 5 million. It then asks for the long-term population. Now this means that as t gets larger and larger and larger, what happens to the population? Now, one key factor is that if we have e to the power of minus x, then as x gets larger and larger and larger, this tends down towards 0. The graph approaches 0 as x tends to infinity. So in our model here, as t gets larger and larger, tends to infinity, this part here will tend towards 0. So therefore p tends towards 7 take away 0, i.e. the population tends to 7 million. So again, an e to the power of minus x or minus t graph will tend towards 0 as the variable gets larger and larger and larger. If that tends to 0, then that whole term tends to 0, so therefore the population will approach, in this case, 7, and that's the long-term behaviour of this population. Now, in part 2, we're then asked to find out what k is given a condition. Now, we're told that when t is 1, the population is 5.5 million. So p must be 5.5 when t is 1. So 5.5 equals 7 minus 2e to the minus k. I've let t equal 1. So to find k, we must rearrange this equation to get k equals. So we do this in quite a few easy steps. I begin by taking away 7. So 5.5 take away 7 equals minus 2e to the minus k. I can then divide by minus 2, and that of course is minus 1.5. So minus 1.5 over minus 2 equals e to the minus k. If I now apply logs to both sides, then I get ln of, the negatives cancel off, 1.5 over 2, ln and e cancel off, so I get minus k. So therefore k equals negative ln of 1.5 over 2, and if we put that into our calculator, we get k is equal to 0.288 to 3 SF.